Hi, grade 7. This is your math lesson. For 3-6, which is distance on the coordinate plane, lesson 3-6, distance on the coordinate plane. And guess what? It's pretty much a review with a little bit of a twist on this whole idea of the Pythagorean theorem. So, I'm going to start with a problem and show you what's going on here. Hopefully you'll see that the Pythagorean theorem is involved in this pretty quickly. So imagine I have a dot here. And imagine I put another dot, say, right here. And I say to myself, how far apart are those two dots? How far apart are those two dots? Well, I could count like this. 1, 2, 3, 4, 5, 6, 7, 8. And I could say it's 8 away, but that's not really what I'm talking about here. I want to know the distance like that. How far is that? I could pull out a ruler, but what if I wanted to measure it in units? Here's how we do it, okay? I try to figure out a way to create a right triangle based on what I've got right here. And what sticks in my mind is let's take it right down here and straight up here. We've got a right angle right there. The height right here is 2, and the distance here is 6. Guess what? We got enough info to create a Pythagorean theorem problem. Everybody say Pythagorean theorem. Yeah, my ugly teeth. Here we go. So, a squared plus b squared equals c squared, right? And 2 is our a value, so that's going to be 2 squared. 6 is our b value, equals c squared, right? We got 4 plus 36 is 40, is our c squared. We take the square root of both sides, and we get a c value of something a little bit bigger than 6. I don't know what it is. I just know it's 6 because 6 times 6 is 36 and 7 times 7 is 49. So I'm going to turn on a calculator here and press it in, and I get 6.3. 6.3 is my value. And the label for this is units because we're talking about the coordinate grid, and the label on coordinate grid problems is units. UNITS. So that's an example of how we do this. I'm jumping right into one of your problems now. All right? One of your problems puts a dot at 1, 2. I believe this is problem number 4, if my memory's right. Puts a dot at 1, 2. And the other dot's at 5, 4. The other dot's at 5, 4. And we're going to try to figure out how far away these two dots are. 1, 2, 3, 4, 5. 1, 2, 3, 4. How far away are these two dots if we're traveling like that, right? So first thing I do is I think about how can I make a right triangle? I'm going to go across and then up, and here's my angle, and so this would be my hypotenuse, my C. This is my A, and this is my B, right? Smallest side is A, second smallest side is B. The side that is opposite the right angle is C. What are my dimensions? This is 4, B is 4, and A is 2. I got enough info. I can solve this now. So, a squared plus b squared equals c squared. A squared plus b squared equals c squared, right? This is 4, and this is 16. They add up to make 20. Now what? Well, need to take the square root of both sides of the equation, right? And I get a c value equaling to whatever that is. I'm thinking it's somewhere between 4 and 5, so we punch in 20. Yep, 4.5 units is the answer to this problem. And this, folks, is problem 4. This is your first problem of the assignment. Okay? So all of this should be on your paper shortly. Now, What I want to do next is make sure you remember how to identify locations on a graph. First of all, the quadrants. Where are the quadrants rather. Quadrants. Where are the quadrants on this? If you remember that this is quadrant 1, this is quadrant 2, this is 3, and this is 4, that's awesome. Quadrant 1, 2, 3, and 4. This is our x-axis. See the x there? Our y-axis up there. Got it? Good. Okay. Now, how do I identify dots? Let's review that. I'm going to put a dot here, another dot here. I'm going to put a dot here, one here, and one here. How do we identify them? Always think x first. X first. So if I'm talking about this dot right here, where is it in relationship to the x-axis? It's right above 0 on the x-axis, right? Because this is -1, this is +1, +2, -2, right? This is +3 and this is -3. This is location 0. It's above 0. And where is it in relationship to the y-axis? It's at 2, isn't it? 1, 2. So that's 0, 2. Okay, enough of that. And what about the other dots? Where's this one? First of all, where is it in relationship to the x-axis? It's at location 3. Where is it in relationship to the y-axis? It's at 0. It's across from 0. So that's our location for that one. How about this one right here? In relationship to the x-axis, it's at 2. In relationship to the y-axis, it's at -4. How about this one? Where is it in relationship to the x-axis? -2. Where is it in relationship to the y-axis? -3. How about this one? Where is it in relationship to the x-axis? -3. Where is it in relationship to the y-axis? +1, right? +1. So -3, +1. Okay, hopefully that's enough for today. Thank you. Shouldn't be too hard. I hope not. Yeah, you might need some graph paper. It's over next to the window in the black tray if you need some. Bye.